Hello, I am Jasper van der Vaart. I'm a researcher and software developer at the TU Delft. One of the projects I work on is the IFCEnvelopeExtractor. This is a software BIM2GEO converter that takes IFC files and creates city.json files based on this. This is not a one-to-one translation of the data in the IFC model. Instead, it creates an abstraction of the data that is geometrically based on the extended LOD specification created by the TU Delft in 2016. This output can thus be easily used in downstream GIS applications. In this video, we will cover how to set up the tool with the help of the graphical user interface. This video will not cover an in-depth explanation of the inner workings of the application, nor an explanation of the terms. For this information, it's recommended to visit the GitHub page, which can be found following this QR code. The GUI has been created to allow users to easily interact with the application. It allows users to change a subset of the settings, and it gives direct feedback. There is a Python and executable version available. Both versions run the same underlying code. The pre-built executables can be found under the Releases tab. When clicking on Releases, a list of different available versions can be found. The version with the latest label is the most recent stable release. The executable can be downloaded by clicking the version you require, either the Windows or Linux version. If a pre-release version is available, this version can also be used. However, it will possibly be less stable than an official release. After downloading the executables, they can be placed on your PC at any desired location. However, for proper use of the GUI, it is important that the GUI executable is placed in a folder together with the 3 pre-built application executables. When the executable is started, it will show 2 windows, the GUI and a console. The GUI is used for the user to interact with the tool. The console is used for the tool to communicate with the user. Closing either one will terminate the other. Looking at the GUI, we can see a range of settings, some of which are more self-explanatory than others. Hovering over a setting will give a hint, explaining what the setting does. However, we will go through each setting from the top to bottom in this video. Selecting the input files can be done with the Input IFC Path browser. By clicking Browse, a file opening prompt is opened. This can be used to browse to the desired file path. Multi-file IFC models are supported. The paths can also be filled in manually via the text bar. Make sure that each path is separated by a space. If the path itself has spaces in it, make sure to put the whole path in quotation marks. The output path setting follows the same logic. However, only a single output path is allowed, because only a single output file is made. The application does not make new folders, so if a new folder is required to place the file at the submitted file path, the folder has to be first made by hand. If not, the process will not be started. The desired LOD can be selected in this part of the GUI. All the selected LOD abstractions will be stored in the same file. The voxelized output is marked as LOD v.0. This is not an officially recognized abstraction for city models, but it does approximate the shape of the building closely and quickly in 3D instead of 2.5D. Based on the selected LOD, the Additional Setting tab will update, because not all the settings are applicable for all the selected LOD. The Generate Footprint tab will prompt the application to create a footprint at the height of the input footprint elevation. This will be a horizontal section through all the objects at that height. If the Generate Footprint tab will be deselected, the roof outline will be placed at the footprint height. If both the footprint and the roof outline output are disabled, but LOD 0.2 export is desired, the tool will alert the user that it cannot execute this request. For LOD 0.2 output, either one or both of these options should be selected. Aside from LOD 3.2, the voxelized output, and the LOD 0.2 footprint, the outer shell abstractions are based on the geometry of the roofing structure. If this is not desired, the output for LOD 1.2, 1.3, and 2.2 can be restricted to the footprint shape. This can be done by toggling the Footprint-based Abstraction tab. If the interior objects are desired in the abstracted output, the Generate Interiors tab should be selected. This will create geometry representing the stories for LOD 0.2 and the interior spaces for the LOD 0.2, 1.2, 2.2, 3.2, and voxelized output. If the input IFC file does not have IFC space data included, only the voxel output will approximate the interior spaces. The other LOD abstractions will not have spaces included in that case. The Approximate Areas and Volumes tab will force the application to use the results from the voxelization to compute the areas and volumes of the outer shell and, if interiors are selected, of the stories and the rooms. The accuracy of these approximations depend on the selected voxel size. The voxel size has a default value of 1, but in most cases this should be lowered. Between 0.3 and 0.5 is suitable for most simple buildings. Depending on the desired output, this value can vary. A rule of thumb: use the smallest size that still processes within a reasonable time. This is a trial and error value. A whole video could be dedicated to how to calculate the suitable voxel size without using this rule of thumb, and this video might be created, but the topic will be passed over in this video. The footprint elevation can be selected here. This value was covered shortly during the footprint generation setting. It does not only dictate the height at which the footprint section is taken, but this value also dictates the height of the ground surface of all the LOD abstractions, except the LOD 3.2 and voxelized one. This value is not always 0. It depends on the way the model had been created. This value can be found by opening the input file in an IFC viewer and measuring it. For example, in BIM Vision, the coordinates of a slab representing the ground floor can be accessed via Measurements and the Coordinates tool. The Z value of this found coordinate is the proper footprint elevation. This entire section is related to the space-dividing objects. The space-dividing objects are the objects that the tool uses to create the abstractions. Any object type that is not shown in this text box will be ignored by the tool. The box is populated with the default space-dividing object. These can be removed with the toggle. The IFC building element proxy type can be added with another toggle. This will suffice for most IFC files. However, if it is known that certain types should be evaluated that are not included in this default object list, the box can also be populated manually. To unlock the box, the Custom Div Objects toggle can be clicked. There are two small remarks here. The text box is not case sensitive, and each type must be split by a space. When this is all set up, the Run button can be clicked. This will start the application. Its progress can be monitored on the console. It communicates the input that is received and the steps that it is taken. Based on the complexity